Mama.
Prakash sir, good evening sir. We welcome you sir.
Yeah, good evening, madam.
How are you sir?
I am fine. I am fine.
Yes sir, thank you sir,
Yeah,
thank you.
yeah.
We'll wait for another 10 minutes sir, let the participant join, then we'll start our program sir.
Yeah, surely, surely. I'll just mute now. Okay.
Yes sir, yes sir.
Yeah.
Once everybody have joined, I'll let you know sir.
Surely, surely.
Yes sir, thank you sir, thank you.
Thank you. Thank you.
Mama. Yes. Mama.
Logi Chon, sir, we welcome you, sir.
Yes, sir. Yes, madam.
Yes, sir.
Welcome you.
Yes, sir. Yes, sir.
Okay.
Okay, sir. Thank you. Prakash, sir, we can start, sir. Once again, we will start with the formal invitation, sir.
Surely, madam. Whatever process is there, you just follow it.
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Okay. Hmm.
We can start the program.
Good evening, everyone. Thank you for joining us today. We are excited to have you at today's 5-day International Virtual FDP on Mathematical Insights, Navigating Trends in Modern World, organized by Department of PG Mathematics of PSDR Krishnamal College for Women.
Let us collectively seek the blessings of the Almighty. May His grace guide our endeavors and illuminate our paths as we delve into the realms of knowledge and understanding.
Together we gather not only to celebrate the elegance of numbers, but also to explore the profound impact of mathematics on various fields and unveiling the intricate of tapestry of its applications in our modern world.
Now I would like to call Dr. T. Brinda, Associate Professor, to introduce our intellectual guest speaker, Dr. R. Prakash sir, and also address the gathering.
Good evening, one and all. It's my pleasure in welcoming everyone for this 5-day International Virtual FDP on Mathematics and its Applications. I welcome our Dean, Mathematical Sciences, Dr. L. Laxmanan sir, Head of the Department, Mrs. K. Sarmila ma'am, and faculty members. I extend a warm welcome to all the participants who have joined from various institutions all over the country. I heartily welcome our invited speaker, Dr. R. Prakash, Associate Professor, Department of Mathematics, RB College of Engineering, Bangalore, to deliver a lecture on mathematical insights, navigating trends in the modern world. A small introduction about Sir. Sir is having 23 years of teaching and research experience in this field. He has published more than 20 research articles in reputed journals. He has delivered around 25 talks in various workshops, seminar, and conference. He is a member of International Association of Engineers, Indian Society of Theoretical and Applied Mechanics. Also, he is a member of BOS and BOE committees and has received many awards. He is also a book reviewer, external examiner, and external guide. So, we are grateful to have such an eminent person on this occasion. With this small intro, once again, I welcome you, sir. Thank you for accepting our invitation, sir. Once again, I welcome you all. Thank you.
Thank you, madam. Thank you for the introduction. I will stop my video so that disturbance will not come.
Okay, sir, no problem, sir.
Thank you for the introduction, ma'am.
Without further ado, we warmly welcome Dr. R. Prakash, whose expertise and insights are sure to enlighten us on the topic Mathematical Insights, Navigating Trends in Modern World. The session is yours, sir.
Yeah, thank you, madam. And firstly, I thank Brinda, madam, and HOD Mathematics, PSGR College for Women, and also principal of PSGR College for inviting me to deliver this lecture. Maybe I'll share the screen first. Am I audible?
Yes, sir. It is very clear, sir. No problem.
Okay, then I'll share the screen. Let me know whether my screen is visible or not.
Yes, sir.
Is my screen visible?
Yes, sir. It is visible.
Okay, so I think you can see that slide.
Yes, sir.
Yeah. See, in today's talk, I have 2 parts. One is I have some few slides I want to show you, and then later on I'll go with as usual like a whiteboard explanation of a few examples. See, in this 1 hour virtual, it's very difficult to give you full detail of any kind of concepts or anything, but I can give you overview of how maths nowadays, mathematical trends in this modern world, that is what this modern world, and how these mathematicians can make use of it especially that MSc, those who are pursuing MSc Mathematics, BSc Mathematics, there are a lot of opportunities actually. So those things I'll highlight. So with whatever we are actually studying, okay, that's what my idea here. So I hope my voice is clear and my presentation is visible to all of you.
Yes, sir.
Yeah. Okay. The title of the talk is Mathematical Insights Navigating Trends in the Modern World. Okay. So maybe like in the entire current scenario, like how mathematical concepts, especially mathematics means both statistics as well as mathematics, applied mathematics, play a vital role in building many models actually in industries and all. Okay. See, this is what my first slide, like maths and the making of the modern world. Okay. See, if you just observe here, starting from your satellite and how this Google giving information to all of us, even that iPod, whenever there is a security issues comes, some kind of coding, even robotics, how they are helping now, and some kind of modern gadgets, which are all actually helping our lifestyle better actually. So earlier it was not user friendly. Now many things it is user friendly only. I mean to say, like if you want to do some kind of research in the earlier days, it was very, very difficult to get at least one paper also to read. So nowadays it's very easy. All are in fingertips. So everything we can see through our mobile only. So that's what the for all these, mathematics play a vital role actually. See, there are some common views. Like I hope you might have also faced this. There are some common views on maths and mathematicians. So people say mathematics is completely useless. Some people say mathematicians are evils, kind of thing. Okay, all mathematicians are mad. So many formulas. So what that formula will give you, and what is the benefit of learning that, and many things. So these are all the experiences we every day we are actually come across, and even today also many people feel like that. So generally, some of the students they feel that so maths is a very difficult subject in their studies. So these are all some of the views, but actually truth is different. The truth is totally different. See, this entire modern world, what actually we are now existing latest technology, so it does not exist without mathematicians. And there are a lot of work involved, background work, I can say background work involved in creating many models actually, latest model. Even with mathematicians, you can tell future, I mean to say predict, you can have prediction, and you can save lives. The words lives I have made. So I mean to say some kind of like if you take agricultural sector or medical field, you can have some kind of prediction models where you can predict like in future there is some like nowadays there is a water crisis in almost all part of the world. So this water crisis we can predict maybe in future, maybe another 5 years if you start predicting. So what will be our water crisis or water level of this entire world, so that we can take some precautions. So that is what this math will help. And also for my knowledge, like mathematics is just like a language, how we learn our mother tongue, it is just like that for science and engineering. So mathematics is just like a mother tongue for science and engineering. So without this there is no term called engineering, okay, even science also. So these are all few examples what I connected, like in the previous slide what I said. So these are all the 3 key factors why we need mathematics. Okay, so for that, few example, if you consider, just say here, see this Google page ranking. I have just given one slide at the end of this. Even internet, so security, like using a number theory concept here, number theory. So, and electromagnetism, like almost all fluid mechanics, even partial differential equation, many things like Maxwell equations plays a vital role actually. Even error correcting codes like group theory, Galileo's theory, I can say abstract algebra. Even medical imaging like kind of transforms. So you can say Fourier transform. Here also communication also they use Fourier transform. And some medical statistics, Nightingale. So, okay, so these are all some of the famous contributor to all these examples. Okay, and this mathematics really have made the modern world possible. So this is very important. Okay, so that is the intent. That is the motive one should have, like while studying mathematics. Okay, we have to give inspiration or motivation to the learners. Suppose if you are a teacher, so you have to motivate the students that these are all the opportunities in the mathematics field or any field. You can just mention any field. So these are all the opportunities, but maths play a vital role in updating yourself as well as updating the system or optimizing the system. That is very, very important. So the key to the modern world, this is the one thing you should remember, is the information. I hope you know this. What is information is all about? Can anyone? Information is nothing but data. So this data is nowadays taking a like I can say big trend. So information, like if you read on newspaper, there is some information that you can call it as a data only. Okay, so it may be ancient data or any kind of galaxy or satellite images data, or normal personal information. So like our Aadhaar card, any kind of data which is stored in the computer, or any kind of digital signals or digital boards. All these maths help to do this. What is that? It will store, transmit, and search the information carefully. This is very important without making any mistakes. Without making any mistakes. Okay, this is.
Participants, kindly mute your audio.
Okay, so this is very important. So you remember, information is very much required. That information is nothing but our data. With the data only, this modern world nowadays, mathematics changed its shape actually. And this is one simple illustration I have given, and I'll give you more.
So we could not hear your voice, sir.
Your voice is not audible, sir.
His mic is muted.
Yes, sir, we have informed. Prakash, sir.
Now, am I audible?
Yes, sir.
Yeah, I don't know. It is muted. It was muted. So I hope this is clear. This is explained.
Yes, sir.
Yeah. I just highlight this. See the key to the modern world is the information. Information means data. Information means data. So it may be anything like any old, ancient information, any galaxy information or satellite information, anything, our personal information like Aadhaar or PAN card, any kind of information. It may be stored in a computer, that information, or any kind of information like this. So maths help us to store, transmit, and search the information carefully, also without making any mistakes. That is very, very important. That is what we call it as error reducing. So minimizing the error. Okay. So when you talk about minimizing the error, the concept of calculus play a vital role. Am I audible now?
Yes, sir. It is clear.
Okay, fine. Thank you. So if anything like that, please inform me, because once I share the screen, I cannot see that Zoom platform. Okay.
Okay, sir. Okay.
So just as a simple example, I have taken this. This may be the last slide. Later on, I'll go to the other mode. The maths behind Google. See, the Google searches information. Again, information means, as I said, it is a data. It is stored in websites or like any kind of database. Each website is connected by a network, like many networks it is connected. I mean to say, if you search like Google Scholar, or I can say if you search network theory, if you search network theory, it is connected by many web pages will open here. So it is given by order actually. So order means that maybe first 4 you consider as it will give you more information. So very, very important. I'll stress this word, more information. The maths behind that word more playing very, very important role. So it is assigned by a rank, something called as rank. That is what we call it as page rank. Page rank. It is actually calculated by this. So maybe they are using probabilistic models as well as eigenvalue, eigenvector concept, eigenvalue, eigenvector concept. They are making use of it and try to find out the ranks, and accordingly the search engine will automatically rank the pages. Okay. And suppose that you can do for many computers like this. To calculate that, we need eigenvector. Very, very important. This I'll come back to this again. So why eigenvectors are more important? Because for the larger matrix, doing like this normal thing, it's not possible. So they make use of eigenvalue, eigenvector. I mean, it is nothing but solving the eigenvalue problem. There we can get this page ranking and all. Okay. So this is what about I want to convey these things as a preamble. So now I'll just go through a notebook. Is my whiteboard is visible?
Yes, sir. It is visible.
Yeah. So in the modern world, see, whatever concept we are learning, because I heard that you're all MSc mathematicians, mathematics people, and also UG and PG students, those who are having mathematics background and other backgrounds. So whatever it may be, you might be studying calculus. You might be studying calculus. It may be calculus means anything like differentiation, integration, differential equation, optimization. Many things will come. Many things will come. So even some algebra you are going to study. So it may be linear algebra, abstract algebra. So many things like that. Even you might have studying differential equations. It may be partial differential equation, ordinary differential equation, anything you consider. So one or the other way, So whatever model the industries are engineering they are making, so either they consist of algebraic or a calculus part or differential equation part. So without mathematics, nothing, no word called engineering. So we can call that engineering itself is nothing but applied mathematics. So engineering itself is nothing but your applied mathematics, nothing else. So for that, I'll give you few insights how mathematics is very, very important in nowadays trend. So let us start with the data science, something called as data science. I hope you might have heard this data science. So data science is the science of, I'll just give you one-line definitions only. Science of deriving insights. Science of deriving insights from the data. From the data. So very, very important. Deriving insight from the data. See, remember, data means information. Suppose if you are in calculus, there are derivatives. dy, first derivative, second derivative, third derivative. Those derivative values at particular point, that may be the information. In integration also, you are integrating area of particular regions, one area, two area, second area, third area. They are all considered as an information. Okay, nowadays, I mean, we need to try to connect all these solution, whatever we got, and which concept you are applying for getting the solution, that is totally immaterial. Whatever output you got, that the information, that play a vital role. Actually, that changed the entire mathematical, I mean, what was there, the mathematical prospectus, they actually changed a lot after this data science. Okay, what are the insights? Insight means you can find out average, nature of the data, so many things you can find out. That is what data science is all about. Science of deriving. Remember, science of deriving the insights. Next, come to the I'll just keep this machine learning. Just so short form ML. So this is nothing but again science of, say, I'll just highlight this, science of human learning. Human learning. Very, very important. Science of human learning. How science of human learning means it will learn the models actually. So learn the models. I will explain about what is model is all about. That allow them to reason and make decision. Suppose if you want to have an automated vehicle, like driverless vehicle, so it has to learn so many things, like obstacle, if anything in front of it, like any object, maybe pole or any road is damaged or humps come, that corresponding image has to be identified by that sensor. So automatically it will make decisions. That is what this ML is all about. Science of human learning. Now, you remember there are two kinds of things here. So one is we have models. When you talk about models, two things are there. One is function approximation. So this is what mathematics here, function approximation. And the second one is classification task. Classification task. So what is function approximation? It look like this. Mathematically, if I want to say, it will be function of, see, y is a function of x1, x2 up to xn. comma, there are P1, P2, like Pn. See, these X1, X2, Xn, these are all the inputs actually, inputs. Y is the output in engineering terminology. These are the parameters. These are the parameters. Something like these parameters, how it is very important means something like you say like Y is equal to mx plus c. That is line equation. This m and c are the parameters. In order to fit a line, this is a straight line, right? In order to have a line like this, these parameters are very, very important. So we have x, see we have x, we have y. These are the xy datas, experimental information. I want to fit a line like this. So if you want to fit a line, the role of M and C are very, very important. That is what we call it as parameters. So now you remember in a simple way, Y is a function of this. Okay, input feature, there is an output, and also it depends upon this parameter. Even if you take your Y equals mx, so this m is something called as scalar. Okay, scalar. So you can just say like converting rupees to dollar or anything, this scalar multiplication. You can say scalar multiplication. You may treat this as one vector, this as one vector, and this x also as one vector. So the scalar multiplication may be used in many ways, like converting rupees to dollar. You may have something like that. So that is what scalar multiplication. Okay. So in this machine learning, finally, we have two things. One is algorithm. One is algorithm plus another one is data. See, when you say algorithm, these are nothing but mathematical steps. That's why we need to remember wherever algorithm comes, the entire thing is nothing but mathematical steps. Once everything is done, you may get output, whatever results we are getting. So that is our data. Okay, this ML play on these two only, algorithm and data. I hope my voice is clear.
Yes, sir.
Yeah. So now if I take simple example of these applications, or I can say applications, just I'll quickly highlight some of the things. Like one thing is a prediction of cricket score. Like how we can predict a score. Suppose there is one match. So we want to know how much they may possibly score. So that depend upon the previous record. I mean to say this ML model will take the previous record and it will predict something like this team will score around 300 runs in this match. So it may not like that you will get 300 run, but approximately if you get like 275 to 300 or 300 to 310, so that means you are achieved around 85% accuracy. That is what very, very important. Even we have something called image tagging. I'll just come back to that a little bit later. 1 second. There is another task. What I said is classification. So I'll just highlight here only. So classification means you have to say like this. We have again the function h of x1 to xn, p1 to pn, that is equal to 1 if all x will equal to is less than some quantity, say c, or x1 is equal to c, class 1, 0 if xi is equal to c2. I mean to say, if you get number 1, you classify that as class 1 group, and if you get number 0, you class it as class 2 group. So that is what classification task. Suppose if we have a triangles like this, if we have a plus symbols like this, so there are two class. This is class 1 and this is class 2. So what ML algorithm will do is, it will train Suppose if you have an image of a car, bus and all, we need to identify. Why we need to identify means, as I said, whenever in automated vehicle, even in the army, so they are identifying the objects in the far distance. So they have to identify such that automatically it will identify whether it is a human being is there or physical object is there, any kind of thing. So later on it will classify, okay, it is a physical object, name it as 1. So if you get 1 as the symbol, so they think that it is a physical object. If it is 0, there is a human is standing there, some reference they will give. So that is what classification task. So when it comes to a classification task, that's what I want to say. There is a called as image tagging. This is one of the application of image tagging. So you might have learned all your smartphones. There is now photo tagging. I mean, all your friends' photos are grouped actually. That is what you are tagging. So there is one symbol called search option in the photo gallery. So if you go to that, you will have images of your friend actually. If you click that, whatever photos the particular friend have, so all will be stored in one place. That is what we have classification. It will classify according to the image. It will recognize, okay, this image belongs to this particular person. So this is what these are all the applications nowadays. This entire thing, the mathematics is behind. Now there is one more topic called as artificial intelligence. Artificial intelligence. These are the three things, buzzwords, I can say, roaming. I mean, in the current trend now. So it is again science of mimicking. So mimicking human intelligence. See, ML is human learning. Here, human intelligence. We are trying to build alternative human intelligence using this artificial intelligence model. So that human intelligence. This is very, very important. Okay, for all this, the main thing is like this. All whatever model they do, either in ML model or artificial thing, so mathematically, entire thing will be expressed in the form of y equals f of x only. This we are all mathematicians, we are all familiar with that. This x in the engineering terminology, we call it as input. Y in the engineering terminology, we call it as an output. So entire thing, this f will be the relation. This relation, see, this relation may be deterministic. It may be random also. I mean, all probability models random also. So probability models, and this is deterministic means all mathematical model, like theory or. I mean, you will have an exact proof of that. So that is what. So this f, it may be differential equation. So we can say like differential equation y double dash second order derivative. It may be a function of, remember, so independent variable inputs. These are all the inputs, y as well as y dash. See, remember, these are all the inputs. These are all the outputs. Solution of the second order derivative will be differential equation will involve x, y, and y dash. Like anything you take, it will be function like this only. So this is very, very important. Even in the classification also, we express in the form of y equals f of x. Okay. Now I'll give you few example how mathematics can consider. Suppose if you have a vacuum cleaner problem, so how mathematically it can be addressed. Vacuum cleaner. So there are 2 points, P1 and P2, that is 2 places where there is one is dirty Two options are there, binary case. Another one is clean. If it is dirty, what actually it will do? So it will clean. So the task is clean, or action will be cleaning. And if it is clean, move to next point, move to next point. So this is what. So again, in the P2 also, dirty, clean. If it is clean, move to other, move. Like that, so many things are there. So you just consider this also, like A equals function of P. P is nothing but inputs. We can say points for that vacuum cleaner. And this A is nothing but action done by that vacuum cleaner, action. So remember, again, there is a mathematical formula, y equals f of x. So we have something other example. If I consider, see, you take another example, medical diagnosis system. So medical diagnosis system. There we have something called as inputs will be, P will be the inputs, say symptoms, test results. We have test result. Maybe we have visited another hospital, or some tests we have done before going to that. And doctor will ask some questions. That is what patient will answer. So these are all the inputs actually. So many things like that. And what is the action? Action by the doctor will be, he will ask you question first. How many days, from how many days you are facing these symptoms and all. And even he will ask for some test request, do this test. And even he can go for treatment. And even you can refer some hospitals. So if it is not possible to treat. Again, this A is an action. That is the doctor actually. And this P is for the patient's information.
Okay.
Similarly, we have, I'll give you one more simple example and then I'll move on to the next one. Suppose if you have like a taxi driver case. These are all how, like nowadays, they are making use of all these mathematical concept, especially that statistics and probability, and making use of the data which is available in the real scenario. They make use of that data and try to analyze and make a model. That model is a mathematical model. This is what we call it as a model. Y equals f of x is the model. Anything, it may be a continuous or discrete. You take whatever concepts you might have studied, everything will be in this form only. So the taxi driver, you want to have driving, if you want to go, he has to take care of this safe drive. And also sometimes he need to move fast, and he has to get maximum profit also. So these are all some of the things in his mind. What are the action you want to take according to that? He has to, for steering, he has to concentrate for the safe drive. And also for the fastening, he has to accelerate. And the profit, he has to go with the short route, like that. So these are all the actions. So again, A is a function of P. See, these are all some examples in the current trend, how they made everything in the data collected. The data is available. The data collection they made. Once the data is collected, they go for the model. How model? So they will go via plotting only, simple plotting. They will came to know how the data is spread out. And from for that data, they want to fine tune the data, means they go for the machine learning models. Okay. So that is what the things in engineering is going on. Okay. Now, in the summary, if I say, see, we have something like this. So this is your DS, data science, and all learnings. Say something like this. See, we have AI, artificial intelligence, ML, deep learning. This is deep learning. See, when the data is large, they are going for ML model, DL model. When the data is moderate, they will go with ML model. Okay. So for entire thing, it is involves in DS only, data science. When it comes to data science, so full of mathematics is involved here. That is what. So that is what the idea here. The real secret. So this is very important. The real secret is in data science, AI, ML is purely very important, purely depends on mathematical principles, mathematical principles and tricks to utilize it. If you remember these words, it is more than sufficient. Tricks to utilize it. Okay, I'll tell you what is mathematical principle means. So these are all comes into picture. Linear algebra. These are all the things you are going to study, like how vector space and all useful in data science. I'll just highlight those things. Calculus. So there we have like all network theory uses calculus. Statistics. Probability. Optimization. So this is what mathematical concepts very, very important. Okay. Then tricks to utilize it. This is nothing but your programming, computation, algorithm, programming. So comes into picture. I mean to say, if you have thorough knowledge of mathematics with little knowledge of programming, even if you have a thorough knowledge of mathematics, learning programming is very, very simple. And nowadays there are very user friendly programmings are there, especially if you have a Python knowledge. It's very simple, just an implementation only. We need to know how to implement it. That is what the Python will help you a lot. Earlier it was MATLAB. Actually nowadays MATLAB also something programming is required here, but nowadays they also made most of the things are user friendly only, and open sources like Scilab. So there are many things. So the learning programming is not a big deal. So just you can learn if you don't know anything on the programming, just learn Python. It is more than sufficient. So all these concepts along with Python will help you a lot, and it will fetch you very good job. If I consider, maybe it will be there for another 10 to 20 years, minimum 20 years. So,
participants, please kindly mute your audio.
okay, madam, am I audible?
Yes, sir, it is clear, sir. You can continue.
Okay. See, these are all some of the scopes which MSc students can look into it, because if you just study mathematics as for teaching profession or any kind of banking job and all, it is of no use. So you have to make use of the current trend actually. So that's why learn these concepts, application oriented concepts with applications, and also learn some basic programming. So that is what Python I suggest, because it is very simple. There is no rigorous programming is involved there. If you know some mathematical concept, it is more than sufficient. So these things plus Python will fetch you very good job with I package nowadays. Okay, you may just learn some kind of data analysis, at least data analysis. Courses, you can just join free courses only using NPTL, Coursera platform. I hope you might have learned all those, aware of these kind of platform, even Udemy. So there you will have a lot of opportunities. Actually, grab the opportunities. Simply don't get the degree. So apart from degree, you should get a good job also. That is very, very important. So because trend will be there in another 20, 30 years, it will be ruling. This entire thing will be ruling. So that's why it is an opportunity for all of you. Please try to utilize it properly. Okay. So if you come to how this mathematics has taken shape, I'll go with simple example. Okay. If I say vector, can you tell me what is vector? Anybody? Vector is a physical quantity having magnitude as well as direction. Correct? Magnitude and direction. So this is what we generally define vector. But other way around, I can say like this. It is a carrier moves something from one place to another. One place to another. Move something means direction. Moves something means magnitude. Same meaning only. How we denote that vector? Vector is denoted like this. X equals x1i plus x2j plus x3k. What you do is, just for the time being, just ignore all this. Ignore all this. I'll just write like this. X equals x1, x2, x3. You just call this as 3-component vector. 3-component vector. What actually connected? How it is connected? Now it is connected. It is connected to data science or ML or AI. How it is connected? That is very important question, right? So now I'll just explain. I'll give one example here. Just follow this. Suppose you have like around number of students placed with 8 lakh per annum. 8 lakh per annum from, maybe you might have 10 sections. You just imagine there are 10 sections in your college of 60 strength. Each section having strength 60. In each section, I want 10 sections. I want to know how many students will get 8 lakh package after placement. So what actually you do? So you have to represent that information, right? You can call it as x1, x2, xn. I mean to say there are 10 sections, x10. So you call it as a component of vector. And now you need to fill something, right? So this is nothing but your variable. They call it as future. In their engineering language, they call it as future. And now x1 has some information, some data. I can say randomly there are 5 students got 8 lakh. In the second section, these are all 10 sections. 10 sections. See, this is how they are modeling. So similarly, in the 10th section, there are no students who got placed with 10 lakh. So this is some information you are going to get. They have collected like this. So once it collected, it is nothing but we have 10 by 1 matrix or vector. When you come to a matrix, when the data is converted into a matrix, we can do a lot of things. I'll give you another example. Say you are scanning, you are reading a book. Say one page consists of arbitrary page consists of around 25 lines. Around 25 lines. So I want some information, the engineer or somebody, your recruiter wants how many times the word network is appeared in the 25 line page appeared. What you do? Tell me, you represent this information now. How to represent it? So there are 25 lines. So you have to generally call it as x1 to x25. So each line has so many words. In that, I need to identify the word network if it is there or not. In the first sentence, this is the first sentence. This is the 25th sentence. I have only one word called network. I have two words. There are no words here. Like that, there are 5 words in the 25th page. So this is what we can call it as 25 into 1. So 25 dimensional vector. Okay. So this is very, very important. You remember, this leads to what you might be studying. This leads to this kind of information. What they are doing, they are collecting information like this, leads to vector space. You might have seen this type of symbols, V of f or Vn of f. If f is the field of real numbers, see, just remember, don't worry about the actual definition and proofing and all, just ignore it. You have to go, you have to look into the application part. You just call this field of real number is the domain of interest. See, in mathematical terminology, I say real numbers, complex number, etc. See, real number means any kind of data like crop yield of a crop, or production in a company, production in a factory. When it comes to a complex number, you can say some signal, telephone, communication signal. It may be in the form of real part as well as imaginary part. So this kind of domain is nothing but this. If you are dealing with some kind of signal analysis, go with the complex number set. If you are dealing with other than that, you can go with any kind of real number set. This n stands for n dimension. So V stands for vector space. You might have studied all the properties of vector space, how it is and all. So they have some significance, like why we need to study vector space, why subspace is required, why linear combination is required. So they're all very, very important. And why basis is required. So if you know all these things, it's very, very important to know why we need to study linear combination of this, why we need to study basis for that. Okay. I'll give you a glimpse of that when it comes to, because I want to give more example of this. So this is what one thing you should remember. And when it comes to solution, I'll give you some examples. If I say like solve x plus 2y is equal to 3, 4x plus 5y is equal to 6. Can you tell me what will be the solution of this? Anybody? You can do it by calculator also. If you tell me, I'll just connect this in the different form. Something like this, in engineering terminology, we have something like A, and we have an output called as 3, 6, and this will be your question mark. This is your input, and this is your output. So this we call it as matrix in mathematics. So in engineering terminology, they call it as a system. So now what input will produce 3, 6 as an output under the system A? What will be the answer for this? Anybody?
X is minus 1
minus 5 and y
and y equal to 2.
Very good. So we have something here like minus 1 and 2. Now I want to know the geometrically what is that actually. So there is a 2 lines here. Agree? I just wrote roughly. This may be the first line. This may be the second line. This is what the line of intersection. So it is 2 lines are intersecting geometrically. It is a case of unique solution. Unique solution. You might have learned this. Case of unique solution. I mean to say geometrically 2 lines are intersecting at single point. Now I'll take another example. Please try to work out. I'll just hold here. Sorry. I want all this. So I'll give you another example. Please try to solve this. Solve x plus 2y is equal to 3. These are all simple things. This play a vital role in linear algebra. So 8y is equal to 12. Now tell me what is this?
The equations are linearly dependent.
Yeah, dependent. Very good. So linearly dependent means same lines, same line we have. I can say geometrically both line coincides. So maybe what will be the solution? There are many points here. They are all the solutions actually. So we can have case of what? Infinitely many solutions. Many solution. Now there is another case I'll give you. Solve x plus 2y is equal to 3 and 4x plus 8y is equal to 6. Tell me what is this? What will be the solution here? You can use anything. Like if you just draw the lines, you will get like this. Correct?
Sir.
Yeah. So yes, very good. Case of no solution. But the question say solve. What is this? Tell me. I mean to say geometrically what that 2 lines are never intersect. 2 lines not intersecting. Not intersecting. See, I'll just correlate these things for the real situation. Maybe after your plus 2, I mean 12th standard, from your aspect, my means student aspect, you have a lot of options actually. Okay, you can do master. I mean, you can do arts, you can do medicine, you can do engineering, you can do science, or you can go for diploma courses or fashion design. Anything. There are many things. But from the parent point of view, due to the various parameters, they say you do MSc mathematics only because maybe your father or thing they are the teachers. You do B.Ed only, Bachelor of Education. You do nursing kind of thing. They stick on to that. You have only one option, unique solution, case of unique solution. Whereas here, from your point of view, so as I said, there are many options. You can choose one of them. Infinitely many situations you have after your plus 2. But you are choosing one that is the best solution. Best solution. Okay. Overall, what I can say here is, see, first one is unique solution. Unique solution. It is the ideal situation. Everything is perfect. Ideal situation. You are having vehicle, your father is dropping you to the college, you are coming back, father is picking, or any of your family member is picking, and you are nothing to do, so you are the ideal situation. Okay. Secondly, there is infinitely many solution. Infinitely many solution. Many solution. In that case, you have to pick a proper one, pick a suitable one. Suitable one. And the third case, no solution. What we have to do here? Tell me. See, these two, nothing to do with this. Here only picking the best solution. That's all. But main task for the mathematicians or an engineer is to address this no solution case. So example, you might be traveling to one place. There may be some obstacle happened, road has damaged. There is no other route. You have no other options to go to that place where you want to route. But you have to find out some case approximately. That is what approximate. Try to find approximate solution. Approximate solution. When you say approximate solution, numerical method comes into picture. Numerical method, all numerical method algorithms they are using. Okay, approximate solution means, suppose if you have y and you have like something y1, this error should be always 0. This will be the error. So you have to reduce the error. That is what actual engineer applications are going on. Reduce the error. So all more projects what they are handling, they try to reduce the error. Say like banking project they are handling, say example, Infosys company are taking care of SBI Bank. All customer database they are handling. Sometimes some glitches happen. I mean to say, next time they want to reduce that error. It should not come again. Sometime it default, whatever you send the money, it will not go. So all those things, that is what this one. All problems, real world problem are having like this. We need to, or problems having some error, try to reduce that error. For that, mathematics is the like what I can say, play a vital role in doing all this. So these two are the user friendly. Is it clear? This is one thing you should understand about solution, because when you come to any kind of real problems, real world problem, one thing they say, what will be the solution? So once you say solution, they may use any kind of techniques. Okay, any kind of techniques they are using. This vector playing it is just like a backbone for that all ML algorithms actually. So if you dig into any kind of data science books, so how this linear algebra, vector space, linear combination, all those things play, I mean how they are taking all these concepts into picture, so that you will came to know. I'll suggest some of the books. So next come to another thing is called as eigenvalue and eigenvector. So these are all some of the concepts you should not forget, and all entire thing follow this one only. I mean, ultimately, any information you can bring into a vector form. Vector in the sense matrix. Matrix theory comes means it is all linear algebra concept they can use. And if you want to arrive a solution, they want to use kind of applications, I mean concepts like eigenvalue, eigenvector, or solving a differential equation, again converting into eigenvalue, eigenvector form. So that's what optimized such situations. If you want to find out that optimized point is nothing but eigen point or eigenvalue, and the direction which you are moving, that is nothing but your eigenvector. So just remember like this, if I take like this 1 2 2 1 and 1 0, tell me what is the output of this. It is just like multiplication only. 1 2 2 1 0 1. What will be the output of this?
1 and 2.
1 and 2. Yes, this will be 2 and 1, correct?
Yeah.
So then 1 2 2 1 and then 1 2 1 2 2 1 2 1. What is this? 1
5,
into 1, 5
5
4.
and 4.
Yeah, this will be 4 and 5, correct? This will be 5 and 4. Okay, now just keep aside these things. I'll go with another one, another set. I say 1 2 2 1 and 1 1. What is the answer here? Then 1 2 2 1 1 2 2 1. This is a simple example. You can find it in any linear algebra book.
3,
1 2 2
3,
1.
3.
Yes, very good. 3 3. And what about this? 1 2 1 2 2 1. Again 1 2 2 1 and then 1 1. What is this actually?
9, sir.
Yes, 9. And it will be 27 default because of that. So can I say like this 3 into 1 Can I say like this 3 square into 1 Can I say like 3 cube into 1 Yes or no?
Yes, sir.
Yes, sir.
Yeah.
Yes,
Now
sir.
what I want is I'll just 1 second. Okay. See, I'll make use of some kind of geometry here. Just follow this. We have x and y here. We have input. These are all the inputs. Say 1 0 here. See 1 0. What is the output actually? 1 2. 1 2 means somewhere here. So this is your 1 2. Correct? So I'll just draw a line here. 1 2. First line. So go to the second one. 0 1. There is 0 1 here. 0 1. I hope this is correct. 0 1. Yes, y-axis. And then 2 1. 2 1 means somewhere here. See 2 x-axis 2, y will be 1. Maybe somewhere here. So this is your 2 1. Are you following what I'm doing?
Yes, sir.
Yeah,
Yes,
1
sir.
2. You give 1 2. You give 1 2. 5 4. 5 4. Maybe 5 here and 4 maybe here. So I'll just take this 5 4 like that. See, this is like this. Another one will go like this. Now observe this. Observe this. I'll just write the same thing. Same thing. I don't have space, so I'm writing fast. So that please bear with that. I hope. So first one is what? If I give 3 3, somewhere you will have 1 1. Somewhere 1 1. What about next? If you see, this is nothing but this entire thing is nothing but 3 3. Like that. If you give that, you are moving somewhere here. You are moving somewhere here. Correct?
Yeah, x equal to y.
Yeah. I mean to say, just observe this graph and this graph. Can you tell me what is the difference? What actually happening here? I'll just recall again. We have something that is what we call it as input. This is your system, maybe your car. You are giving some input means brake, accelerator, steering. You are giving some information here. That is your car. Sorry, I'll not use that. So this is the matrix again. This is the output. Okay. What actually happening in the first case? Whatever input you are giving, see, you are giving 1 2 1 0 0 1 1 2 and 2 1. This the output is not in your hand. It is going somewhere else. You cannot say like what will be the output in the next case. If I give 3 4, what will be the next case? What about here in the second case?
It coincides.
Coincides, and you can say after 5 years you can just see you have made one model and you are put for input and you went for simulation and you're given for computation. See, after 10 days if you come back, you can easily say, see, one day it moves like 10 kilometer. After 10 days it will be 10 into 10, so it is in the at a distance of 100 kilometer. You can easily say like here. Correct? You can easily trace out the information here. That very, very important. The word is very, very important. You are tracing the information very easily here, whereas here it is very, very difficult. Those who are all cricket lovers, I can say, those playing of Virendra Sehwag, who plays cricket. So whatever delivery the bowler bowls, so he will send the ball to all corners of the ground. Yes or no? Whereas
Yes.
you might be seeing that Dravid and maybe you can, those who are cricket lovers, they can remember this word, Michael Bevan of Australia. Michael Bevan. Whatever delivery you go, either you give short pitch, outside ball, leg side ball, whatever, long pitch or haircut. So they will send the ball to the same direction. You can just observe whether it may be 1 run, 2 run, 4 run, that ball will be moving at the same direction. Means whatever input you give, direction will be on the same line. I mean to say that is what data science is going on. Mean information, they don't want to lose it. That is what very, very important. That concept is called principal component analysis, PCA. So principal component analysis. So for this, eigenvalue, eigenvector plays a very, very important role analysis. See, this entire thing, whatever I have written here. So whatever I have written here, if I correlate, so mathematically, what is that? See, we have something like A is our 1, 2, 2, 1. So we have how many times? 3 times we have. So A cube into X is your input, is equal to 3 cube into X. Yes or no? So equivalently saying that Ax is equal to lambda x. This is what your eigenvalue problem. So this is very, very important in principal component analysis. I'll just briefly explain how it is. Can I continue, madam, for another 5 minutes? Hello?
Yes,
Hello?
sir. Please proceed, sir.
Yeah. If it is more time, please ask. Tell me. I'll stop. Okay. Okay, sir. If it is boring, also you just let me stop. I'll let me know whether to stop or not. Okay. See, this is very, very important. This comes again in the linear algebra concept. See, we have like Vn of f, as I mentioned in the earlier case. So this vector space will follow so many definition, like axiom 1 to axiom 10. If we are mathematically, if you want to study, the last axiom will be 1 into u will be u. The first axiom will be alpha plus or u plus v belongs to vector space V, correct? So these are all in between. There are many examples. Like you have a data set, as I mentioned, in data science language, you consider anything like whatever you say, like in pure mathematics thing, they just say numbers. You just forget that numbers, you give some physical meaning. I say 30 line page I send, the x1 to x25, the 25 page line, how many numbers of number of times the word network appears. Like we have data, this is nothing but 25 component vector, 25 dimensional vector. Okay. So we need to verify whether this forms a vector space. We need to check all these axioms. It's very, very difficult. Even for that, they went on to subspace actually. Subspace means trivial case where if we satisfy it, u plus v and c into u belongs to v, and another thing, one condition is null vector. 0 belongs to V. If these 3 conditions are satisfied, we call it as a subspace. So now 11 axioms reduced to 3 now. Okay, but still verifying this for 25 component vector, verifying all these, again it is a difficult. What they have done is they have gone through some kind of linear combination. What is actually linear combination? You can express this vector as a linear combination of some vectors like this. I mean to say, some information you can collect with the combination of this. So you no need to verify all these axioms. You just express the entire thing is as sum of this. So what actually you can say, you can trace, you can track this fellow. That is more than sufficient. All other information you can get to know. I mean to say, you have a class of 60 strength. Like I have 10 benches, like 6 students in one bench. So first row, second row, third row, fourth row, like the 10th row, like this. I don't want to collect the information like this. If I want to collect myself all 60 students information, very, very difficult. I will say one representative here, class representative, first row, representative for the last row, 10th row. I will do like that, representative. So what I want some information from the first bench, means I'll catch this fellow. This fellow is a combination of these fellows. So I'll get an information. That's why linear combination is very, very important. Okay, in that linear combination, again, so many combination will come. So many combination. Correct. Again, it is again difficult. That's why they went on basis. What is basis? Basis is nothing but first condition is linearly independent. Second condition is it spans the whole space. Again, linear combination spans the whole space. Linearly independent means, see, these 60 students, 10 benches are there. The information given by class 1 representative, information given by 10th representative is coinciding. The same information they are giving, or they are handling the same project. Take one of them, ignore other one. That is what dependency. All dependency you remove. Then, so this 10 row becomes 3 row. So for me, for a teacher to handle these row people, I mean 30 people is very difficult, very easy. 3, 6, 18 people, very easy rather than 60 people. That is what linearly independent. So that's why they consider basis. Still, this basis giving a problem. They are going with some kind of componenting. That is what we call it as principal component. I mean to say, we have an information like this. This information, whatever I am writing here, this is nothing but each one having vectors like U1. It has some 10 information. This data is more. Okay, when the handling the large set of data, it's very, very difficult. What they do is they will go with some components. This components means a combination only, which has having larger information. Compare that information you word, that is very, very important. Remember, whenever you say something like eigenvector as the information which is more compared to other information. If you go with the eigen direction, you are not going to lose many information. I mean to say, you are going in a Google map, some of your relatives gave some address. They will say so many information. One information, if you follow, you are going to reach the destination 90% chance. So that is what the idea here. So you are not going to lose the information. That is what your principal component analysis will play. So many data which are linearly dependent, they will ignore it. So for all this vector space is playing vital role actually. So in that again, they are going for orthogonality. Still this basis again difficult. Orthogonality means they are considering only the vectors which are orthogonal to each other. Still they want to reduce, means they are going for the normalization. Those vectors having length 1 and orthogonal to each other, they are considering. So our entire data, 1 lakh data now becomes only around 100 data. So that is what this linear algebra play a vital role in all this. So in this principal component analysis, our eigenvalue problems, eigenvalue and eigenvector is the major role actually. So eigenvalue and eigenvector is the major role involved here. So that's what kind of mathematics involved. This is simple thing what I gave you, because in this 1 hour I cannot tell you more than that. It is actually very, very difficult. So similarly, there are some kind of statistical concepts which are very, very important. You might have learned those things, or learned already, or you are going to, please, you try to learn those statistical concepts also. I'll just give some of the things in PDF format that will be very, very very, very informative. So apart from that, I want to give you some of the things. You can have something like, I'll say, motivational videos to get interest in mathematics. Please watch this video on synchronization. This is a very beautiful video done by Steven Strogatz. If spelling is wrong, please bear with me. So this is a very, very interesting video. So he is a very beautiful, mathematicians. He gave kind of mathematical concepts through videos. Please go through this video. It will be a motivational for you people. And even there is one thing called as mathematics for machine learning, mathematics for ML, and as well as AI. This is by Andrew Ng, Andrewng. You can click this and you can watch some YouTube. You will came to know he's an engineer. He's the main architect of artificial intelligence now, entire world. Okay, so you will came to know how mathematics is useful there. All simple partial derivatives and data, how they are collecting, even house prediction, agricultural yield, and leaf disease. All are real life problem we are all facing. So the same problem, the water crisis, all the same problem they are collecting in terms of data. From the data, they are moving towards engineering application. So for that, collection, modeling, and analysis, full of mathematics is involved. There is another professor in Coursera concept. There is one professor called Jeff Chansho. So these are the three professors' videos. Please watch at least for 10 minutes, 15 minutes in a week. You watch this, you can subscribe all these. So definitely you will have different aspect, different way of understanding mathematics after watching all these videos. Okay, there are some good books connected to this one. You can just try this practical linear algebra. This is very, very important. Practical linear algebra by Foreign Hansford. So this book is actually really very good book. So you will have a lot of information, visualization of linear algebra concept. When I say linear algebra, it's full of mathematics only. All your differential equation, PDE, and anything like discrete mathematics, all the information they are bringing in the form of a matrix ultimately when it comes to a data science. And there is a concept, one more linear algebra book, linear algebra pure and applied. You might be having this in the syllabus copy. This is a very important book, Edgar G. Gordon. So this is one book you can follow. And there is one book on multivariable statistical analysis. This is a very good book actually. Multivariable. I'll give you this book's link, Statistical Analysis by Anderson. So this is actually a very good book, Andrew. Okay. And learning from data by Gilbert Stein. So this is also a very good book. Please refer this book. At least you can just take applications which are done here, and that will be the reference for you. And there is one thing called, you can search in the Google after this, mathematics and industry. There is one article actually, I'll show you that now. Mathematics and industry. So how industry using this mathematics, applications of industrial applications of mathematics. So you will see how mathematics are using. But we pure mathematicians, we are caring about only proofs, prove the theorem, prove the axioms and all. We need to change our mindset and we look into the application part. Maybe in your syllabus there is called network theory. It is very good actually. Just concentrate on that. Maybe you may have artificial intelligence also. Try to concentrate more on those courses. This will be the point of understanding the concept. It will be there always. See, whatever I have done linear, whatever I have explained, basis, principal component, it involves theory only. Background is theory only. The theory will help the programmer to write the better program. That axioms, that 11 axioms will help the programmer, that engineer who write the code So that is very, very important. He has to take care of those 11 axioms. That's why axioms are very, very important. So, but engineering application is there. You have to model, mathematical model, and get the result. To do that, these are all very, very important. Madam, can I stop?
Yes, sir.
Actually, sorry, it is too late.
No problem, sir, but it was very informative.
1 second, I'll show you one more thing. See, this is what the article I am saying. Please,
Okay,
you
sir.
can just have that. So,
Yes.
mathematics and industry, it is freely available. So, there are some information actually here. It is freely available. You can just check. It is very good article actually. Some kind of theory they have written, but you have to understand how maths is playing a vital role. So these are all some of the applications. So starting from this, mathematics as an innovation enable for industry. So starting from results and all, you no need to worry. Read this and try to collect some and try to make a note of this. So how this article will help you really good actually. So just this is what I want to say. And I'll share some of the books, madam. You can just share to the participants.
Sure, sir. Sure, sir.
Okay, I'll just 1 second, madam. I'll.
Yes.
Okay. I hope I have not bored, and to the best of my knowledge, I shared the information. Might be many things you might have known. With this 1 hour virtual, it's very, very difficult to explain the entire mathematics involved there. But I'll try to, if there is another opportunity, I'll take some real application, maybe taxi data, and how we connect with the mathematical model and how we can get the solution through programming. I'll try to do that in the next whenever I get an opportunity. But whatever I have given, just I can say the ideas how mathematics, the engineers, they are making use of this mathematical concept. They are getting benefit. Now the mathematicians, we are the mathematicians. We are struggling too much for proof, for getting result, but we are not getting good package. The reason is this one only. So because we need to move towards application, so forget about the proofs and all Gauss divergence theorem, Stokes theorem, and Hahn-Banach theorem. How many times we have to prove? So 1,000 people, lakhs together people already proved. Just ignore that. Just take the concept and move out of that. How on Banach space, Banach space will help in topological learning, machine learning. So that's why. So please move in that direction, especially for the PG students who are in the second semester, final year. Please try to take some courses on data analytics and try to learn Python programming. It really help you a lot and get into the job of data analysis at least. Don't go with only teaching job or any other. It's not like teaching job is not good, but it is good. The only thing is if your research background is, if you are strong in research background, then you move to the teaching field. Otherwise, get into this job, earn money, and settle your life at the early. That's what my advice. Thank you.
Thank you very much, sir. Hope our brain is filled with of all books and other information, sir. Thank you so much.
Yeah, madam.
Yes, sir.
Okay. So I thank once again the opportunity which was given by PSGR College, and also I thank the participants for patient listening. Thank you.
Yes, sir. Formal vote of thanks, sir. Please do,
Yeah.
sir.
Okay, madam.
Thank you, sir. We sincerely thank you for dedicating your time to us, sir. And your insights were not only enlightening, but also motivating. So your valuable perspectives on mathematical insights, navigating trends in modern world, garnered high praise from all the attendees. You have made the information very clear with your picture depiction examples, sir. Your significant contribution played a crucial role in the success of the event. We express our heartfelt gratitude for generously sharing your knowledge with us, sir. Thank you so much, sir.
Yeah, madam. And another one request is, if any students are interested to do kind of thing, like there are applications here in our college, there are some center of competence actually, especially for higher, final year degree students. If they are open to that, they can apply to our college. Definitely, I'll help them. They can
Sure.
do live project only, and they will be paid. Incentives will be paid like around 25,000 per month. They will pay 25 to 30,000, depend upon the project,
Yes.
and it will really help them. And also, they can complete their research work at the earliest. So they after that they will really get into good job actually.
Thank you, sir. We'll follow, sir. Sure, sir.
Yeah.
Participants, if you have any queries, you can post it in the chat box or you can unmute yourself and ask the question to sir. Sir, we had one previous question by Anil Mercy. She has asked, what is the app you are using for teaching, sir?
This one teaching, now whatever I taught, writing board.
Yes, sir.
Yeah, anything, madam. So actually, this is iPad I am using, and anything like a note is there. OneNote. See, you can see here. I think I have OneNote or Good Notes is there. Good Notes. There are many applications are there. They can download and do it. So I'll show you once again. See, there is a Good Note. This is Good Note actually. And OneNote. There are many things are there, madam. They can use it. Yeah.
Haripriya, you can go for the next question.
Sir, one more person also had posed a question in the chat box, sir. Dr. Akhil Mittal has asked, do you have something application of math in chemistry, physics, etc.?
Yes, yes, sir. See, again, chemistry, if you have, see, maths, physics, you cannot separate with maths. No doubt in it. Maths and physics parallelly it will go. See, if you look into the chemistry, there is a kind of applications where your structure, like compound structure, like there is a concept called chemical graph theory. Even there are concepts called as graphical machine learning models. Okay, so we can make use of that kind of information, whatever bonding structure and all, so that the information we can go with the chemical graph theory, and in turn we can have machine learning models for that also. It is there actually.
Thank you, sir. Participants, do you have any more questions? You can kindly put it in the chat box or you can unmute yourself and ask the question.
Yeah, somebody has asked, can you post some information? Definitely, I'll share some of the information in making like short notes kind of thing. It will be really useful. Please try to find out those information on the website. It is available, freely available. No need to pay anything. And just make a short note of this and I'll send you.
Thank you for answering the question, sir. Before moving on to the votes of thanks, I would like everyone to switch on your video for the group photo. Participants, kindly switch on your video for the group photo.
One second, madam. I'll.
Thank you everyone for switching on your video. Now, I would request Dr. Anita, Assistant Professor, Department of PG Mathematics, CSDR Krishnamurti College for Women, to present the vote of thanks.
Thank you, Haripriya. On behalf of Department of Mathematics PG, PSG Krishnamal College for Women, Coimbatore, it's my great honor and privilege to propose the vote of thanks on the second day of 5-day International Virtual FDP on mathematics and its applications. First and foremost, I thank our speaker, Dr. R. Prakash, Associate Professor, Department of Mathematics, RV Engineering, College of Engineering, Bangalore. He has graced this occasion in spite of his busy schedule. His valuable presentation generously shared his expertise, insights, and experience throughout this session. Sir, your presentation have not only shed light on the intricate role of mathematics in deciphering the complexity of the modern world, but have also inspired us to search deeper into the realms of mathematical thinking and application. I also extend my sincere thanks to all the participants who actively engaged in discussion by raising thoughtful, provoking questions and contributed to the vibrant exchange of ideas. Participants' enthusiasm and commitment to learning have been the driving force behind the successful of this program. I would like to record my gratitude to Secretary Dr. Yashoda Devi and Principal Dr. Meena for their encouragement and support. I also extend my thanks to Mathematical Science team, Dr. Lakshmanan, for his constant support and guidance. I thank Head of Department, Mathematics PG, and faculty members for their coordination, dedication, and execution of every aspect of the successful event. Last but not least, I thank all the participants from various places who made this event a successful one. Thank you all.
Thank you, madam. Thank you for valuable information. And also, I want to thank Principal, HOD Mathematics, and faculty of the Department of Mathematics of PSGR Krishnamal College for Women for giving an opportunity. I hope in future any kind of collaboration is required. Definitely, we are ready to help. So, in terms of student project or anything, so that student will be benefited. Thank you, madam.
Thank you, sir. Sure, we'll follow your words, and it's a pleasure, sir.
Yeah, thank you.
Thank you, sir.
Thank you, madam.
Feedback form is posted in the chat box. Kindly fill the feedback form.
Participants, tomorrow the timing is by 11 a.m. to 12 noon. So kindly join 10 minutes before.
Participants can kindly leave the meeting after filling the feedback form.
அனிதா என் மீட்டிங் கொடுத்துடலாம்னு நினைக்கிறேன் அனிதா.
ஓகே மேம்.
இல்லாமா? ஏன்னா மேக்ஸிமம்
Participants
எல்லாம் நம்ம போட்டாச்சு, இன்னும் பார்ட்டிசிபென்ட்ஸ் இருந்துட்டு இருக்காங்க.
எஸ் மேம், we can end the meeting now.
என் மீட்டிங் கொடுத்துடலாமா?
எஸ் மேம்.
Okay ma'am, I'll do it.
ஒரு நிமிஷம் அனிதா. எல்லாரும் என்ன சொன்னாங்கன்னு எனக்கு காதுலயே விழுகல.
மேம் எஸ் என் மீட்டிங் கொடுத்துடலாம்.
ஓகே ஓகே. பிருந்தா மேம், சசி மேம், கிருஷ்ணா, நிலா.
எஸ் மேம்.
என் மீட்டிங் கொடுத்துடலாமா?
எஸ் மேம், we can end the meeting now.
ஓகே மேம். நான் என் பண்ணிட்டேன் மேம். யூடியூப்
ஓகே.
எஸ்